Cute. That was funny. Whoa. That was an interesting solution. Shut up. Time to do number 44 without being able to put this video player into full screen, which is extremely annoying. Whenever I put it into full screen, it automatically goes back to the beginning of the video, which is so stupid. Wait, let me just see. What am I going to do? Correlations. Wait, it's going to be seniority, test 1, 2, 3, performance rating. When potential workers apply for a job that requires extensive manual assembly of small intricate parts, they are initially given 3 different tests to measure their manual dexterity. The ones who are hired are then periodically given a performance rating on a 0 to 100 scale that combines their speed and accuracy in performing the required assembly operations. The file lists the test scores and performance ratings for a randomly selected group of employees. It also lists their seniority months with the company at the time of performance rating. Look at a matrix of correlations. So it's pretty easy. You just select all of them and then do correlations. That's funny.
Periodically given a performance rating on a 0 to 100 scale that combines performance-driven manipulation, your value for the regression.
Okay, you know what? I don't need to even look and see how she did because she already has the answer right there. I should be fine. So, correlations. Stop. This is one of 3 remaining problems left. That's funny. It will involve all of these. We will have correlation. Matrix. Stop. Let's see if we got the right numbers. And we got 0.08, 0.00, 0.05, 0.43. Ha 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 ha. Funny. Good thing I didn't find the password because you're not allowed to see my Wi-Fi password. But I can't even find it. I thought it was on my computer. Oh, man. Dude, maybe I can remember what it is. Oh my gosh, are you kidding me? It didn't even... Okay, I found it. You cannot see it. Ha. You cannot see the password. Ugh. I got it. Do we have the same numbers? We have 0, 0, 8, 0, 0, 0, 0, 0, 5, 0, 4, 3. We have 0.59, 0.65, 0.58, 0.79, 0.5. I don't know why you can't get a correlation between performance rating and all this stuff. Like, what's the point? Like, why can't I get a correlation between this and other things? What on earth? Like, why? Why does it only show half of them? Why does it only show half of the correlations? But, oh, I'm a dumb. There's only one that's above 0.7, but there's also a couple there above 0.6. That was funny. Oh, man. 0.59, 0.65, 0.7, like 0.59, but not 0.56. What's the cutoff? R squared. What are we looking at? R squared? Where'd you get the R squared anyways? How did you do the R squared thing?
Will be at least 35%. Why or why not? I would never ask a question like that on the exam.
Can you say with certainty that the R squared will be at least 35%?
I like this question because it makes you think, about the connection between the correlation between individual variables and all the variables. Again, to get this correlation table, you would have just gone in and opened up the data analysis tool pack, selected all of the variables, and gotten your correlation table. Of course, performance rating is the variable that we're trying to predict. That's our bivariable. And so we want to look at the correlations between all of our predictor variables here and that performance rating measure. So 0.432, 0.583, 0.522, and 0.615. So that is the Pearson correlation coefficient, R, right? Well, goodness of fit is R squared. So I just took each of my R values and squared them to get the R squared.
Oh. I'm dumb. That's actually pretty obvious. R squared. Why doesn't Control-Shift-Plus work? Why doesn't it work? Why? I looked it up. That's how you're supposed to do it. Control-Shift+. What? Why? R squared. I'm just going to do caret 2. Whatever. Equals this caret 2. And then go across. And there. Now I guess we'll just change all these to point. No! Oh no! Okay. So point 19, 0.34, 0.27, 0.38. Did she do 3 decimals? Decimals. Decimals. 0.18, 0.34, 0.27, 0.37.
So if you take and look at which of these values is the largest, the 0.379, this would be the minimum R squared that you would have, or actually that should be maximum. That would be the maximum R squared that you would have. So yes, it's going to be accurate within 0.4, so that's because R squared is 0.37.
Maximum R squared is equal to this. So we know that the R squared with all variables in the equation is at least as large A. A, yes. A, yes. One of the R squared was above 35%. I mean, that's what I'm getting from that. It's worded very weirdly in the answer. The 3 test score, okay. Multicollinearity will be a problem. The 3 test scores are fairly highly correlated. Test 1 with test 2 is 0.5, test 3 with test 1 is 0.6, and test 3 with test 2 is 0.79. 3 test scores are fairly highly correlated, so they probably won't all be needed in a regression for performance rating. The 3 test scores are fairly highly correlated. Dang it! I forgot how to spell correlated. So they probably won't all be needed for in a regression for performance rating. I'll just highlight this. I'll just highlight these. I guess like she didn't highlight this because we weren't really looking at seniority. We were just looking at, well, I mean, seniority is highly correlated with test 3, but it's not highly correlated with the other 2 tests. But it's not even that high. Oh, wait, never mind. I'm stupid. It's 0.05. I'm dumb. Oh, jeez. There, I think that's good. You know what? I'm just going to skip the rest of this. We have answered A and B. We're done with part of the question. Whoa! Run the regression of performance rating versus all four explanatory variables. List the equation, the value of r squared, and the value of standard error. Do all of the coefficients have the signs that you would expect? Okay, that's pretty simple. That's simple. I'm just going to see. She probably does.
Moderate level correlation value. Sensitivity heard. Actually, this chart our data, we want to go to the data analysis toolpack. All right, so
That's funny. Oh. Multiple regression. Stop. Multiple data. Stop. Regression. Where's regression? Regression. Input range. We want performance rating as the why? We want performance rating. X will be all these 4. And new worksheet. We have stop. We are going to do things. Wow. So we have p-values listed. The test 2 is going end up seeming to not have a high impact on it. So we end up with, and same with, oh wait, never mind. Significance, r squared multiple r. What is the question C? List the equation. Oh man, I don't know why she didn't list the equation.
the coefficients are positive. That is what you would expect, right? You would expect that, not the intercept, but for seniority, test 1, test 2, and test 3, that there's a positive effect on those things causing the, performance rating to be high. Okay. So then it says to.
Well, that's pretty easy. Dude, she didn't even list the other stuff like the equation, value of r squared. Do the coefficients have the signs you would expect? C. Yes, we would expect them to have positive signs. D. Why did I capitalize it? D. What is D? Equation. If a worker has 15 months, now we have to do a calculation or thingamajiggamajaj. So, I mean, that's pretty easy. Where did you put part D? Oh. Test 1, test 2, test 3. What? Wait a minute. Oh, I see. So that makes it a little easier. D, prediction, we can just put we'll just put it up here. Let's see. D. I mean, we're just going to label it as D. So equals the coefficient plus this times seniority of 15 months plus test 1 times 57 plus this times 71 plus this times 63. So, what is this, performance rating? And also test scores are kind of low. Like, I feel like all these test scores are really bad. They're all around like 60 and 50%. Unless that's not percent, maybe that's just a total. What is the rating here? There, we got a 67.46. So, 67.462. Well, if you say so. I don't want it to be 3, though. I like either 2 or 4. E. E. T values for coefficients. What the heck is E? What does that mean? What is T value? What is T value anyways? No, it's not. Wait. T value? What are you talking about, T value? What are you talking about? I don't know. Don't know. Where'd you even get that T value? Where'd you get that? What on earth? I mean, we're just looking at the P value here. What about the T stat? I mean, T stat. Yeah. Oh.
Yes, they all have the same.
Test 2 is related to Y because Y. What is Y? To Y because of its correlation on the previous sheet. Is related to what? Its low T value and high P value, meaning it is not significant and should be removed from the equation, or because its influence on Y have been explained by the other test scores in the equation. What are you talking about, Y? What is Y? You gotta be kidding me.
So even though the values, and then we have the upper limit
Oh, come on. She's doing the upper and lower limit too? No! I forgot to do the... Eh. Okay, fine. Oh, man. Upper limit. Prediction. Lower limit. Upper limit. Great, now I have to... I'm gonna move this one over here and then do t-value standard error. T-inv equals t.inv dot 2t parenthetical. That was funny. 0.025 comma. How many? Do we just do 2 less than the listed? 2 less than 80, so 78? Is that what we do?
7. And land on my standard error over there in E7. My t-value, again, it's going to be equal to 0 to and e is 2. Value is 2, so 78.
78. I can't even remember the reason why we're doing that. But okay. Wow. We got a t-value of 2.2855.
My upper is going to be equal to...
This equals this and 7.04 or something. This equals this minus this times this. This equals this plus this times this and that. $51.36 and 83.55. I think she messed up. 51 point something or other. 0.36. So there, now we're done with that part. Finally. Then we do E. I was looking up E, trying to how to do E because I couldn't figure it out.
Or whoever is manager could be 95% can be 95% confident that the true predicted value falls between 51.4 and 80.6. Again, if that's too big of a prediction interval, the recommendation is to take a larger sample size. That'll be too big. Part E, one of the t-values for coefficients in part C is less than 1 right here. It's test 2.6. Explain briefly why this occurs. This is what I was saying before. This is the result of the multicollinearity. It's written right here. And then part F says, hey, it doesn't really make sense to do this where you use test 1 and test 2 and test 3 since they have multicollinearity. Why don't you do an average of the 3 tests instead? So if you look here, the average test score was added in, average of C2 to E2.
Hey, guess what? This homework assignment says I don't have to do F, so I'm not gonna do it. That was fine. Test E. E. Test 2. was correlated with the other tests, and this multicollinearity resulted in the high p value. I guess I don't know. I don't even know what I'm talking about. It's still related. I don't know. Like, what does this thing say? It's related to y. Oh, I get it now. It is still related to y because of the correlation shown on the correlation tab. Now I actually get what y is. I'm an idiot. Stop. Test 2 is redundant with the other two tests on the multiple regression. I don't know. And then F, I'm just skipping because it says I can skip. And we're done with that. We only have two more. There's only two more. Oh my goodness. Oh my, stop. We only have two more. Oh, stop. Two more. 51. Please just let me get through this, please. Please. There's only two more problems. Please just be easy. No, it's level B. Ah. No. It's level B. Managers at a large fictional corporation. Years of experience, years here. Management level, salary. Oh no, is management level? Uh-oh. Management level might be a categorical variable. Dang it. No. Well, at least we have the video to help us through that. No. Regress salary on the potential variables. How would you handle the management level? Should you include both years experience and years here, or only one of them? Well, for that one, run a correlation test between them. If they're correlated, then you should probably only include one of them. So, yep. I think I know how to answer that, except for the management level part, and that's the part I need help. That's funny. My goodness, it took her an entire over 20 minutes. Well, I guess that's not that long to do the last two questions, but man, that seems kind of. Is she doing F right now? She's doing F. Oh, that's fun. Yeah, she spent, like, how long did she spend on F?
We see that the values aren't too much different. Similar in terms of all the arguments and significant result.
Okay, 51. We're on to 51.
Data variable in the which is the entry on the potential explain and handle management level. So this is what I was saying the other day. When you have a categorical variable that has more than two categories, you end up having to code multiple dummy variables. So let's say that management level 1 is entry, management or frontline, management level 2 is mid, 3 is upper, and management level 4, which I don't have a dummy variable to explain it, a second, is the executives. So you'll notice that when we dummy code, I use that if statement, and then I just go to the management level that's coded 1 through 4, and if it's equal to 1, 1 is put here. If it's not, then a 0. So
Oh, that's not too
what we
bad.
end up with for management level 1 variable are zeros whenever it is 2, 3, or 4, but when it's management level 1, we see a 1, right? Makes sense. So going back, and then you would do that for 2, right? Same thing, G2 equals 2, then 1 comma 2, and then you would do the same thing for 3, if G2 equals 3. Copy those down for each of your columns. So going back to what happens when it's 4. Well, when it's a 4, all the other ones are zeros. So what Excel does, and if you remember when we did the previous ones with dummy variables, if it was 1, it meant the condition existed, and the coefficient indicated how much different that was for on the predictor variable, right? So if we look at our different management levels, when all 3 of those are 0, that's what management level 4's salary is going to be. Okay. So it'll make more sense when we walk through and explain it.
So that's not that hard. I thought it was going to be more complicated than that. And did she move salary? No, she put salary over here. Well, salary is the y variable anyways, right? So we don't even need to move it. Right? Okay. So we need to move these 2 over 2. No, 3. 3. And then we need to do things. That was funny. What would be funny is if I left it muted. No, I didn't. Management level. So it's just 1. Management level 1, 2, and 3. MGT level. That was funny. Level 1. Management level 2. Management level 3. And then if this equals 1, comma 1, comma 0. If G2 equals 1, 1, 0, and we have 1 there, 1, 1, 1, 1, 1, 1, 1, 1, 1. If this equals 2, comma 1, comma 0. If this equals 3, comma 1, comma 0. Right? 2, 1, 2, 3. And that is not hard. Okay, stop. So, that should be it for dealing with that. And then regress, what's the best way to do it? How would you handle management levels? Should you include years experience and years here, or only one of them, and which one? So probably for that last question, we need to do the correlation thing.
After the fact. All right. So having said all that, let's
Or maybe we do correlation first and then we omit one.
The first thing to do is to look and see if there's a potential issue with multicollinearity. I ran a correlation matrix, and sure enough, it makes sense. The years here and the years of experience are highly correlated. Right? So that's probably an issue. So it maybe makes sense.
This is so great. I have to have them all the cells adjacent to do that. I wish I'd done that first. Man. All right, well. Fine. Data. Management level. Copy. And paste. Well, how do you do the correlation if these are categorical? How do you do that? I mean, it looks like she just did the way I just did, but we'll just see what happens. Oh wait, I'm a dumb. It has to be all these. Output range here. Point. I mean, does it work when you have categorical variables? Such as management level. That's funny. Well, I did it the same way that she did. I got the same numbers. And we have a high correlation here. So, oh man. Years here and years experience.
For us to use only one of them in the equation, but we'll find.
Highly correlated, so probably only one of them is needed in the equation for salary. Years here and years experience are highly correlated, so only one of them is needed for something or other. That was funny. Needed in an equation for salary. And there is some positive correlation in these scatter plots, but it isn't strong. What the? Years between years of experience and years and salary. What on earth are you talking? What are you doing? What is that? What is that for? What are those scatter plots for?
When we look at the individual variables against salary, experience against salary, and years here against salary, they both seem to move up to the right, and it's not a very strong relationship. R squared's 0.18 and 0.17, so not a lot of the variability in the salary is explained by just those two variables. However, let's take a look at multiple regression. Again, what would I have done? I would have gone into my data analysis tool pack
I'm just going to copy and paste that part. I don't really know why that's necessary. Where does it say? It's a little bit more vague, the instructions, so I guess I'll just include them anyways. Salary and experience. Salary and experience. Stop. Sal. Man, like for that one, you've gotta like do even more stuff. Experience. Years here, experience. What's the order that you put this in when you do this? Is the y variable second? Oh, great. You didn't show the scatter plot. So, accelerate years here. Uh, 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 uh. Dude, I don't even remember which one is which now. The top one should be the first one, right? Years experience. I don't even remember which one is which. This is hilarious. Yes, that's right. Here's here. Trend line. Trend line. Oh my goodness. I'm just. There is some positive correlation in these scatter plots. Wait, so why couldn't we have just done the correlation test including the salary in this? That would have made it so much easier. We wouldn't have had to even do the plots. Whatever. Oh, stop. That was funny.
Again, what would I have done? I would have gone into my data analysis tool pack, opened up the regression option. My input would be column I, salary, for the Y variable, and B through F. Do not select column G, or you will get in redundant and unnecessary information. And we can throw it onto this sheet here. Mainly because I have it repeated behind this. We better check off our plots just in case we need to assess assumptions. So again, that output is going to look like this one here. And as we
Weird. We include both years experience and years here, even though we just established that we should not include both of them. Okay, then. The questions we need to answer are what? Well, again, she didn't answer the question of which one to exclude. She just included both in her test.
There is, because that multicollinearity between years here and years experience, it turns out that years here is not a significant predictor. Its p-value is 0.852. So we can bump that from the model. So
years here. Text. Years here has p value of 0.85. We can eliminate it from the equation. So we can eliminate it from the equation. So we're just going to do another one or what?
Then in order to do that, I would go back to my data sheet and open up my data analysis toolpath and start with column C rather than column B and run it again, and I would get this output for here. So we've got a very strong.
So, okay then. Well, I guess that's fun. Oh, I have to switch them. I wish I'd done that before. I bet it's going to mess everything up. Like, watch. It's going to mess all this stuff up when I switch them. Well, not this, but this. Like, is there a way to easily switch? Other than doing stupid copy and paste? I mean, you could use the shift thing, can't you? Can't you use the shift function to switch Shift and then undo. Okay, fine. You wanna? I'll just copy it. I'll just paste, cut and paste. And then this. And paste. There. Now it's switched. So, like it was already switched before. Man. Stop, 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 Steve, stop, 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 stop. Multiple regression 2. Stop. And no, stop. We have gotten things. P-values are low. And did we get the same numbers? 0.95, 0.90, 2.56, negative 38. So it looks like we got it. Okay, so this is a good fit with an R-square of almost 91%. And a standard error of only this. The coefficient of years experience indicates how much more salary a manager earns. For each extra year of experience, the coefficients of the 3 dummies indicate how much less on average the managers at these levels can earn relative to level 4. Well, it looks like I'm copying that. That was funny. That was funny. This is a good fit with an R-square of almost 91%, and a standard error of estimate and a standard error of estimate of only about 55. Doingy doing. The coefficient of years experience. Indicates how much more salary a manager earns for each extra year of experience. The coefficients of the 3 dummies. How much less on average? The managers at these levels earn. Relative to level 4. Text box. Like, do we really need to do the normal probability thing? Because, like, it's not even in the question, is it? Is it really necessary? to include the normal probability plot thingy. The normal probability plot indicates that the data may be skewed as it is not normally distributed. Try a logarithmic transformation of the data. There doesn't appear to be a pattern in the residual plot below. So, why is she doing that? It didn't even ask you to do that.
Relationship, we've got a good fit. 91 for Felicity is 5,000. Experience indicates how much more a salary manager earns for each year as a manager. If you are a frontline manager, you earn $50,687.40 less than if you are an executive level. If you are a level 2 manager, 7 executive level, then an upper level, or then an executive level. All right, so that's sort of the basics with regard to all of that. Again, looking at assumptions, the data may be skewed. It has this sort of S-shaped pattern where it starts sort of up high and then travels across, but it's probably only slightly not normal. Maybe a logarithmic transformation would take care of that issue. If we did the scatter plot of the predicted versus residuals, we don't see any sort of pattern. It's just random across the entire range of numbers.
It's weird how almost every single question, there's only one single question that seemed to ask you to test for the assumptions. I'm not going to bother with that unless it actually asks me to do it. I don't feel like that's fine. So finally, we only have one more question left. Only one more question. Question 52. It's the very next question. That's funny. We have two dummy variables which are both yes and no. Toy company is assigned you to analyze the factors influencing the sales of its most popular doll. Number of these dolls sold during the last 23 years is given in the file. Following factors are thought to influence sales. Was there a recession? Oh, there's three factors. There's doll. Oh, wait, never mind. Was there a recession? Were there dolls on sale at Christmas? Oh, come on. They didn't add the upward trend. Wait. Hey, look, they finally asked you to test for heteroskedasticity, and I now know how to pronounce it. They finally asked you that. Wow, E is fun. Okay, hopefully she does this.
So overall, this looks like pretty good.
Like, was there an upward trend over time? What? What are you talking about? I'm so confused by that. Okay.
It's number 52. In the sales 23 years was over time. Make sure that all the tables in your equation are significant at the 10% level. So they're washing out the 5% significance and pushing it out to the 10% level for us, which again, usually you're risking making an error. You're taking more risk of possibly making an error, but it's not uncommon in social sciences to go out to the 10% level. Or I should say it's not common, it's just not totally. All right, so the data we have is the year, Christmas, recession, and also recession. Intercept our year, our Christmas.
Oh, isn't this fun? Now I have to do the thingamajudge. That's funny. Christmas sale. Recession. If this equals, quote, yes, comma, 1, comma, 0. If this equals, quote, yes, if it's recession, yes, recession, 1, comma, 0. Did she do like 1, 0, and 1? All right, so Christmas sale 0.
And
Yes. Now, wait, this is the last question, by the way. Oh my gosh. Oh, this is the last one. That's one. Dolls sold. These two thingamajodges. Multiple regression. And also, did she do the thingy jiggy?
if I plug those in,
Whoa. Whoa. Whoa, 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 whoa. Where's the question? Ounce. Did she even list the equation for this? Like,
we have our intercept, our year, our Christmas, and recession.
so we got 28, 358, negative 90. No! How did we get different answers? No! How? How? No! Oh, no! How did this happen? We have 1, 1, 1. Dude, I have to compare it and see if they're different results. How did this happen? There's 23 results here. 23. How could this possibly have happened?
Christmas, recession, sold, Christmas sale, and recession. If I plug those
Dude, how did I...
in, we have our intercept.
How did that happen? This should not have happened. Did I accidentally do these instead of these? There's no way. I'm gonna just redo the whole thing and see if I was just a stupid idiot and accidentally did these two instead of these, but I highly doubt it. How could this happen? How could we get different answers? Doll sold 99, 373, 87. I mean, it looks the same for the first 3 cells, so what's going on here? Dolls sold. Should be that. Input X range. These two, did I accidentally do something else for the input range? You gotta be kidding. How is this happening? How? She has to have done it wrong. There's gotta be some mistake. Like the one she has pre-made already there has to be wrong. Because I mean, what am I doing wrong? I'm not doing anything wrong here. I might just have to completely ignore her results because I'm almost certain I did this right. What am I doing wrong?
Those in, we have our intercept, our year, our Christmas.
Part A. Year for trend. Wait a minute. Wait just a minute. So wait just a minute. Do I have to include year as a thing? Do I have to include that? How did you do that though? Please explain. Year. She included year. For trend. So did she actually include the year as a variable? So, are you kidding me? That's weird. I mean, like if I do that, I'll see what happens. Man. I got the same answer that she got now. So we got 120, 28, 358, -90. The p-value for the recession dummy is large, so this variable can be eliminated. So we eliminate the p-value for recession is large, so eliminate. Geez. Save. Now we will eliminate recession and just do year and Christmas sale. So the year and Christmas sale should be correct.
Probably need to label the word (0), and this might well here go to also state in the session for those prediction analysis tool pack, rerun it with just A and B, and this is predictors.
Oh my. A. So A is determine the equation. Well, that's the one. But R squared isn't very large, and the standard error of estimate is fairly large. So does that just simply mean that that equation isn't good? Well, then what the heck is going on here? Oh. So 57, 29, 349.
Year Christmas are significant. The R squared is only, well, R is indicating that it's a strong relationship. Pearson correlation coefficient is a strong relationship, but 52.9%, so about 53% of the variability in the number of dolls sold is explained by these two variables. So that means 48% of the variability is not explained by this model. That seems pretty massive. So I would put the question back to the doll company. Hey, what other things do you think might be influencing number of sales? And that's a pretty slim model between the two variables. All right.
Interpret the coefficients. Unit sales are increasing on average by about this much per year. And the effect of a sale during Christmas is to boost unit sales by 350 million. Well, and I'm not going to include A because the question wasn't even asking that. The question wasn't asking for A. Or for what she wrote for A, because it was just asking you to come up with the equation. It wasn't saying, oh, well, evaluate this equation. It just says come up with the equation. So I don't feel like typing it. Unit sales are increasing on average by about 24 on average by about 29.4 million per year. And the effect of a sale during Christmas is to boost unit sales by 350 million. See, so that's interpreting those values. And what's the answer for C? Are there outliers? I mean, where are you supposed to look for an outlier? Plot to the left of the residuals. You mean to the right? Well, if you look at residuals versus predicted values, it doesn't show outliers. But I guess we'll have to go with residuals. And again, we're going to just delete the residuals one and delete shift on the left. Insert scatter plot. The chart of the residuals does not show any outliers. The chart the plot of residuals of standard residuals versus predicted values doesn't indicate any outliers. D. And what is part D? Is heteroscedasticity or autocorrelation of residuals a problem? So that, well, let me just guess from looking at this. Because, like, heteroscedasticity would show some kind of pattern here, wouldn't it? I don't see a pattern here. But autocorrelation we need to test for, I think.
Having said that, it was a significant model. They want us to make a prediction interval for year 24, which was,
That's going to be for part E.
Raise the significance level for p-value up to 10%, and we still didn't have either one about that. Or I get both
I don't know why she's doing it out of order.
Sales will exceed what value? Oh, okay. I forget they worded this one really weird. So if there's a 1% chance that the sales will exceed a certain value, that means that they want. But there's a.
All right, fine. I'll do it in this order. I don't feel like trying to look for it back later. I do it. E. Stop. E. Stop. 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 E. That's the funny. That was quite funny. Stop it. Stop. E. Stop. E. Stop. 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 I was just going to move this down and do E right here. We need to predictive value. Prediction is going to be what equals this plus the year times what year? $24 plus the Christmas sale times, is there a Christmas sale or not? That's fine. Christmas, 1. So that's it. That's actually pretty simple. I got this. Sold. For what? How many dolls sold? So that's the number of dolls that will be sold this year. So 1111.92. 1111.92. Stop. 99 percentile. Hold on a sec. Exceed what value? How do you do this? What the heck? What is that?
1% chance that the sales will exceed what value? Oh, okay. I forget they worded this one really weird. So if there's a 1% chance that the sales will exceed a certain value, that means that they want the 99th percentile. Okay. So norm.inv of the 99th percentile, our prediction.
Norm.inv 99th percentile equals norm.inv 0.99. And what do we put for mean? B21 is the prediction. And the standard deviation is B7 is standard error. So, and we ended up with a 1714.94.
B21, and then our standard error from cell B7 to give us the value of 1,714.94. So if you wanted to know what value would exceed the 99th percentile, it would be anything above that.
So right. So looks like we got E. Stop. Now please do D. Please do D, which is heteroscedasticity or autocorrelation. The plot of residuals versus fitted indicates no hint of heteroscedasticity. Yay! The plot of residuals versus fitted. Residuals, I'm going to say residuals versus predicted values indicates no hint of. That's funny. No hint of heteroscedasticity. Now we need to do the other thingy. This is the last thing we need to do. This is the last thing.
Outliers. Is homoscedasticity, heteroscedasticity, or autocorrelation with residuals a problem? So, looking at the normal probability plot, we don't really see. It's a little bit squiggly. If we had done our residuals versus predicted, whether the residuals are standardized, then standardized simply means that the scale goes from 0 to 3 and 0 to -3 instead of actual values, but same sort of pattern would emerge. I don't see any particular pattern. The plot does not have any extreme values. Again, if it was standardized, anything above 3 or below -3 would be an outlier. The plot of the fitted indicates, residuals versus fitted indicate no pattern, so no hint of heteroscedasticity. Durbin-Watson is this value in this cell here, 2.52. If Durbin-Watson is considerably different from 2, so what we decide arbitrarily on, stats experts over time have determined that approximately at 0.12 and below 0.12 and above 0.28 is indication of some sort of serial correlation going on. And so a value of 2.53 is close enough to 2, so no big problem with autocorrelation. Okay. How did I calculate that? I used this formula here, which is sum x m y2, which is standing for sum of x times y squared.
Oh my gosh, what is this? I don't even care. I'm just going to copy the formula. I can barely see it because I can't make my screen full screen or it's going to lose my place. Ah, my goodness. Can I just copy it from the book or something like that? Like, where does the book have the autocorrelation thing? I don't feel like trying to. Let's see. It's got to be here, right? Autocorrelation in this part right here. Non-constant error variance. Trying to look. Oh, here's this. Oh. Please give me the equation in Excel, please. There's no way. There's no way. No, that's Stat Tools. They don't have the equation for Excel. No way, dude. No way. Oh. Thanks a lot, book. Now I have to try to read this tiny, tiny little text to get this equation. Great. Okay, I'm just going to copy it into a notepad document first. Seems better. Equals sum x my2. Dude, did she... What is the symbol right there? I can't make it full screen. I don't want to make it full screen. No.
And then you're dividing it by a sum square. But you'll notice that what we're multiplying together here when we do our x times our y, C27 times C48 and C67 times, 26 times to 47. So the difference is one cell later start for the first series and one cell earlier start.
Okay, I'm going to regret this. Okay, 40 minutes. 40 minutes. I can't even read it. I can't read this symbol that she used right there. It looks like a bracket, but I'm not sure. No, that's a parenthesis. Parenthesis stuff.
Is one cell.
Dude, what?
One cell
oh. She's covering part of it.
Start and earlier finish for the second series.
Okay, there we go. So we have a parenthesis, all that stuff, divide by sum, SQ, parenthesis, that stuff. Parentheses, divide by a sum, SQ, parentheses. Okay, I see it now. So it's going to be fun to try to copy this. Sum x m y 2 parenthesis c 20. Oh no. I don't know what C27 is. Oh no. Okay. 27 to 48. What is that? The residuals? The residuals, which I deleted. I deleted those. Okay, I think I should be fine. I'm going to... I'll just redo. Oh no. Dang it. I'm just going to put D on a separate tab. This is so great. I'm going to do data analysis, the exact same thing as before, except D. I'm just going to do D. What the heck? What the heck? Exit. I think the reason it messed up is because it was not on the right tab. Now, it has to be right. It has to be. All right. We're going to do D. We have Durbin Watson. B equals and then so the residuals are going to be on C. I think they're going to be the same for me, right? C starting at 26 and going to 48. It should be the same things. C25, C27, C26. What the heck? Why does it start on 27? Why doesn't it include the first one? That is so weird. Wait. So for the first one, only do it to 48. Or start on the second, the last one. And then go to that, and then go to divide something other, 26 to 48, so include all of them. Okay, so C 27 colon C 48 comma C 26 colon C 47 parenthetical divided by sum S C X S. Oh, I can't see it. I can't see it. I can't see what it says. 40 minutes.
Finish.
Sum SQ. Sum SQ. Sum SQ parenthesis C26 colon C48, and then this should be it. That'd be funny if we weren't even required to do this. That'd be funny. Whoops, did I have equals in there? Yeah. Well, that was a lot of work just to get that number. The plot. Durbin Watson. Okay, actually. C D tab for Durbin. That was funny. That was funny. Durbin Watson test. Also, did I spell it wrong? Wait. No. I probably spelled it wrong because I'm an idiot. Oh, wait, no. Shows no big problem with autocorrelation. Not too far off from 2, so no problem with autocorrelation. And I'm done. I'm not going to watch the rest of the video. I'm done. I did E, right? I did E. I'm done with this. Where's problems? 52. So that's it. That's it. And I'm finally done. Wow, I'm finally done. That's all of the problems. That took 5 billion years. It took me 4 hours to do the second set of problems.